다음은 토카막 네트워크의 블록체인 리서처인 에이든 팍님께서 zk-DEX에 관해서 발표해 주시겠습니다. Private Decentralized Exchange는 어떻게 구현될지 그리고 현재는 어떤 모습인지 무척 궁금한데요. 네, 이제 내려갔으니 바로 무대로 모셔보겠습니다. 큰 박수 부탁드리겠습니다.
Okay, hello guys. My name is Aiden and I'm working as a researcher and author. And the topic of my presentation is zk-DEX, which is a private decentralized exchange. So let's start it. So Ethereum is an awesome project, but there is one caveat. The thing is the no privacy in Ethereum. So all the transaction information are all public to anyone. So anyone can see who sends money to whom and who called specific function in which contract, right? So many researchers keep struggling to solve this privacy issue. So there are some researches about that, zk-DAI for sure, and Maximus, and Mobius, and Ether, and there are a lot of other projects in there. But these projects are awesome, but these projects are only focusing on the simple transfer for privacy. So I just thought that if we add this privacy to DEX, then it'll be awesome. So yeah, that's why we built the zk-DEX. So before explaining about the details about the zk-DEX, we have to know the what we want to keep private in zk-DEX system. So in original DEX system, the procedure of order is like this. So Bob, who is the maker, makes the order with the order data, and in the order data there are 4 data types: source token, target token, and the price and amount. So Bob wants to swap his 1 Ether to $10, right? And Alice, who is a taker, so takes the order because she wants to swap her $10 to 1 Ether. So when Alice sends the $10 to market system, then this market system will automatically settle this order, right? So 1 Ether will be given to Alice, and $10 will be given to Bob. This is the original process, right? In this process, what we want to keep private? Maybe the identities of these traders and the amounts of order, right? So basically, anyone except for these Bob and Alice cannot answer those 2 questions, then it could be considered as private decentralized exchange. So first one is, who are the maker and taker of this order? It's about the identity. And the second one is, how much did they trade with each other? It's about the amount. So, but there are 2 problems on that. The first one is it's even impossible to send money if we do not know the address of other party, right? Even in Gcash, which is private cryptocurrency, if we want to send Gcash to someone, then we have to know the address of someone, which is a G address. But if the address, even G address, which is private address, is public to this zk-DEX system, then the private information is liberated, so it cannot be considered as a private DEX. So that is the problem 1. And the problem 2 is how orders can be settled if the DEX does not know the amount. So let's get back to this. In this step, the market system itself can settle this order because the system itself can know the amount of the order, because the amount is public. But if the amount is public, then it will be not the private DEX, so we want to keep private. But then the market system cannot automatically settle the order. Yeah. this is problem 2. So we made solution for that. First part is smart node and viewing key, and the second part is settlement with GKP. So let's get into it. Actually, zk-DEX is based on the zk-DAI, which is a private DAI for privacy, and it's a very good project, and we did learn a lot of this project from this project. So if you guys know the zk-DAI, then it'll be very, very easy to understand the zk-DEX concept. So let's keep briefly seeing this zk-DAI system. So in zk-DAI, all DAIs are converted into secret nodes. So the nodes consist of the public key and the value. In here, public key is just the address of the owner, and value is just the amount in DAI. But these all nodes are stored on blockchain as a hash and as an encrypted one. So even if someone sees this hash or encrypted nodes, they cannot know the specific contents of the nodes, right? Because it's just hash. And in zk-DAI, if you want to spend the nodes, then you have to prove that you own the secret key that corresponds to public key, and you know the amount of the nodes with GKP. So yeah, so that's why we cannot the specific information about the nodes cannot be built. So yeah, this is zk-DAI, and zk-DEX is a very one of the zk-DAI. So we add 4 data fields to the nodes, which are PK, V, which is public key and value, and the type, which is token type, and the VK is just viewing key. It's for encrypting. Let me explain it about later. And salt is just a random value, and is smart is just Boolean value that specify which is whether it is a smart node or not. So if the is smart is 1, which is true, then the node is a smart node, which means the PK is not the address of the owner. It's just another node hash. This is very important concept. So if you want to spend the smart node, then you have to prove that you have secret key corresponds to public key or public key. It's weird, right? So let me explain more details. So first, public key is the address of owner, and the last public key is just not hash. Because in smart node, the PK is just another node hash, so you just can prove the owner of node hash in the node. Yeah, it'll be complicated, but it's just about the concept of like in Ethereum, EOA can has ownership of another CA. Yeah, that's kind of concept. So yep. And you also have to prove that you know the value of nodes and other data of the nodes. Yeah, this is the base concept of smart node. So what we want to do with this smart node, it's very important to note that you can send money to someone without knowing what address. You can just know the node hash. And node hash is already public on blockchain, so it just not reveal any information about the nodes. So that's the concept. And there is order, and there are 7 data fields in the order, and the maker viewing key, maker node, and source token, target token price, and taker node to maker, and parent node. Is quite complicated, but maker viewing key is just the viewing key of maker. So the nodes, if the nodes is encrypted with this maker viewing key, then only maker can see these contents of the nodes. And the maker node is just the maker's node, which will be traded with taker. And taker node to maker is taker's node will be traded with maker node. And parent node is the parent node of taker node to maker. So it's basically used for making a smart node when maker settle this order. Let me explain about settlement later. So let's first start with the making order. So Bob makes the order with the maker viewing key and the maker node and the source token, target token, and price. So when Alice sees this, Alice can only know about the price, not the amount. So in this process, in this step, Alice have to choose the amount of how much she wants to pay, how much she wants to swap. So in this case, Alice can send 10 die or 20 dice or whatever. So when Alice takes the order, she takes the order with the taker node to maker and parent node. And in this, the public key of taker node to maker is maker node. So if the maker proves that the ownership of his ownership of maker node, then he can spend this taker node to maker. Yep. And taker node to maker is encrypted with maker viewing key, so that only maker can see these contents. And taker viewing key is also included into taker node to maker, so that maker use this later. And final step is the settle order. So it's a one step added because in the original DEX or exchange system, only when taker takes the order, this is the end of exchange, right? But there's one step added. So maker decrypts taker node to maker with maker viewing key. And there are two conditions in here. First one is basically Alice pays less or equal than the amount of makers. So in this case, maker have to get back his money, right? Because Alice pays less. So basically, maker should create the new node to taker and change it to maker from maker node, and create new node to taker from taker node to maker. So it's quite complicated, but this is the picture of this. So you can see in the first case, you can see the maker can get back the change node from the maker node, and or the taker node to maker is its node is will be given to the maker because Alice pays less. Yep. So this is the very complicated version, and I will explain it with a simpler version. So when the maker makes the order, he sends his maker node, which is encrypted, and the owner is maker, and the value is 1 ether. And Alice takes the order, and with the taker node to maker, and the public key of this node will be maker node, so it's a smart node, so that maker spends this node. And the value will be 5 dice. So maker settle this order. So Alice pays less because 1 ether have to be swapped with 10 dice, but Alice only pays 5 dice, right? So maker Bob can get back his change from this maker node. So from 1 ether, 0.5 ether will be given to Bob, and 0.5 ether will be given to Alice. And or the taker node to maker will be given to maker. This is the concept. So in this process, only encrypted nodes and hash of nodes are public on blockchain, and or other information is not revealed. So any third party cannot answer those two questions. So everyone cannot, except for maker and taker, cannot know the identities of traders and the amounts of the order. But there is one problem. Because of the scalability of Ethereum, the Ethereum block gas limit is only about 8 million. But the verification cost of this verified TX, which is verifying the zk proof, is about 7 million. So it's not practical. So that's why we are building this zk-DEX based on the Tokamak network, which is Ethereum-based plasma chain protocol. So in Tokamak network, there is no scalability problem, so we can use zk-DEX with very fast and good scalability. So yeah, it's the concept, and it's just appendix. So you can see more materials about in here, and it's the end of my presentation. And you can give any questions about this zk-DEX. It's quite complicated concept, so you can ask anything about it. Anyone?
한국어로 하겠습니다. 그 디파이 관련해서 이제 디파이가 현실화되기 위해서는 되게 중요한 컨셉인 것 같습니다. 그런데 아까 이제 저도 걱정했던 것처럼 이제 zk가 레이어 1 이더리움에서 돌아가기에는 아무래도 용량의 한계가 있다 보니까 플라즈마를 이용하려고 하신다고 들었는데, 뭐 플라즈마 관련해서 리서치가 많지는 않지만 이제 그 안에서 어떠한 차별점을 두고 플라즈마를 개발하고 계신지 궁금합니다.
우선은 저도 한국말로 답변드리겠습니다. 우선은 그 플라즈마가 주로 포커스가 되고 있는 부분이 이런 복잡한 연산보다는 좀 더 단순한 기능을 구현하는 데 초점이 많이 맞춰져 있어서 이런 zkP를 증명을 할 수 있을 만한 기능을 가지는 플라즈마 체인 프로젝트가 거의 없습니다. 네, 그래서 좀 그런 부분에 초점을 맞춰서 저희는 좀 개발을 하고 있습니다.
Other questions? 또 질문 있으신가요? 네, 네, 그럼 오케이, 알겠습니다. 네, 감사합니다. 박수 부탁드리겠습니다.